So Scott, since we're at Flash Memory Summit, let's take a closer look at some of the announcements that are coming out of this event, which I have to say has become the premier storage event. I mean, this is the storage event of the season for the industry, at least.
Yeah.
You know, a storage developer conference is still, you know, the where it's at for the developer side of the equation.
Yeah.
But from in terms of announcements and storage developments and so on, it's all about Flash Memory Summit.
Absolutely.
So the event is showcasing a lot of what's going on in the industry, and I think that you can get a better sense of the storage industry and the IT industry as a whole by taking a look at some of the announcements that are coming out of Flash Memory Summit and some of the things that people are talking about. And that's one reason that I'm glad to have you joining us today on the rundown, is to try to put some of this into perspective. So let's take a closer look at some of these announcements. We've got bigger and better SSDs. We've got taller NAND flash modules. We've got a lot of talk about CXL and PCI Express and related technologies. We should also look at some of the moves SNIA is making to help the storage industry branch out into data and management, and also giving some continuity to the past of where storage has been, including the SCSI protocol. So first off, let's take a look at some of the products that are being announced, some of these bigger and badder SSDs.
Yeah, absolutely. Part of the fun of this event is it takes you from the bare silicon and takes you all the way up to the end platforms. And so it's that, as you mentioned, it's one of those events where you do have all of the industry greats coming together and saying, hey, look at me, but at the same time, as a consumer of that information, it's a great opportunity to see what's happening next and things like that. So when we think about bigger and better SSDs, how big is too big? So Samsung announced a 256 terabyte SSD on its way. The uniqueness about that announcement isn't so much the density, but the fact that it's kind of mirroring what happened in the hard drive industry around how to make platters work, HAMR, SAMR, dual actuators. It's about the physical space constraints and things and how the market's evolving to allow for that type of an adoption. You have Solidigm, who announced a 64 terabyte drive using QLC technology, which is the first high-density QLC product that can go into a broader set of array of solutions. Everybody thought, you know, you get TLC to QLC, it's, you know, half as fast, twice the density you have to make. It's an opportunity to see those trade-offs kind of disappear as the systems evolve. And then you go all the way to the far end on the client side, and as we see all these laptops getting smaller, bigger, faster, stronger, they can't really sit them in your lap if they're burning your lap. So our friends at Silicon Motion announced a Gen 5 client controller that only consumes 3 watts. And it doesn't sound like a lot, but 3 watts over time in your lap, along with everything else that's attached to it, it's actually a significant change there.
Yeah, and it's interesting that what's going on here in the industry. I will caution people who aren't in the storage space to take some of the big announcements. When it comes to storage, everybody wants to be bigger, yeah. And that's how it's always been. And it's always people announcing the biggest thing. And so, yeah, I remember when the first 30 terabyte SSD was announced, and it was, ooh, that's big. 60 terabyte or 64 terabyte SSDs, oh, that's big.
Yeah. 256
terabyte SSD, ooh, that's big, right?
Next big thing, right?
You know, but take that with a grain of salt, because you know, some of this stuff is more, I don't want to say a science project, but it's more sort of a goal than it is a shipping product. So you have to sort of ask yourself, what's the practical thing that's being announced here? And I think that that's what you're saying here about the Samsung SSD is exactly right. Samsung isn't announcing a 256 terabyte SSD because they want you to go out and buy one. What they're saying is, we believe that we can build an SSD that big, and here's the technology that we would use to build that, which is, I think, a very different and a much more useful and practical answer to the question. In other words, yes, SSDs can grow this big, and here's some of the ways that we can do that using the technology that we have.
Yeah,
Whereas
exactly.
if you look at some of these other SSDs, so Solidigm is going to be delivering the 60 terabyte class SSDs for practical applications, for production right now. I believe that you work for Solidigm.
I do, yes.
I believe that 30 terabyte is shipping, or
the 64 is actually shipping.
It's
so
shipping.
we have customers that have deployed the 30 terabyte class, and quals on the 60 terabyte are in progress.
Okay, so it's kind of getting here.
Yeah, that to your very valid point about announcing something is sometimes a technology announcement more than it is a product announcement. And so you do have to pay attention at this event for those products that are actually in the market, but those that could come to market. Mm-hmm. And you look at the Samsung thing, and I flip over to the aspects of what we're going to do with SNIA. the form factor changes being driven in the market that allow the flash devices to get to these capacities is really part of what that announcement is. It's that aspect of we're no longer stuck in that hard drive form factor. We're actually creating form factors that address the flash needs.
Yeah, let's actually take a little bit of a side trip since I got you here. This is another thing that I would like our wider audience to understand. So for the longest time, the form factor, meaning the physical shape of and size and everything of storage devices, has been dictated by hard drives. So everybody remembers, 3.5 inch, 2.5 inch.
Yep.
Everybody's familiar with that 2.5 inch SSD. That's the same form factor as a 2.5 inch hard drive. But the storage industry is branching out into new ways. So we've got, we got U.2, we got E.3.
Yep.
Tell us briefly, what is the summary for the laymen that aren't familiar with storage? What are we doing with these form factors?
Well, so to your point, SSDs were always doing the me too to replace the hard drive, but you can't really replace the hard drive when that's always an option. You think about why NAND didn't take off like it was supposed to originally is because there was always an alternative. The memory market is a good example. DRAM is doing well because of the AI thing, and there's nothing to replace it. DRAM is DRAM is DRAM, you have to use it. But if I have a hard drive and an SSD in the same form factor and I'm looking at cost, I'm going to go hard drive, and I'll make it work. By switching into the EDSFF form factors and the E3 and the E1.S, they're physically designed for flash-only environments. So now you have servers being built that if you don't buy flash, you can't use the server. And that's allowing us to scale and see that hockey stick really start to take off where flash-based systems are going to be able to be more valuable to the market. Because if you start mixing drives like they did when we first launched them, you got this super expensive, super fast SSD with a bunch of hard drives and you're only as fast as the slowest cog, and it never really helped it. But now with like E3 especially, I can cram 36 drives instead of 24, but I'm also getting density and performance out of it.
Yeah, and I think that that's the important thing, is that we're talking about putting more drives into the system.
Yep.
They're NVMe drives, so they use direct PCI Express. These are not SCSI or SAS drives like the old days, SATA drives. And also the drives, the form factors are designed as well for cooling, and I think that's another huge deal here is, we're seeing more and more of these drives incorporating heat sinks, incorporating technologies that reflect the sort of flow-through nature of the storage, and putting more density into the same space.
Yeah, absolutely. And it's also allowing for what we're also talking about. This event has become a kind of a CXL topic. CXL can't exist if we hadn't come up with these form factors that allow us to put devices in those footprints. So.
Yeah, exactly, because the CXL memory also fits into the same.
They actually built it on an E3 platform. Yeah, exactly. So.
Yeah, and so I think that for our non-storage listeners, I think these are the important things to understand, is that we are finally getting out of the shadow of spinning disks, and we're building SSDs that are SSDs, not just disk replacements.
Exactly.
So let's take a look at chips now. Let's dive a little deeper. So again, one of the things that is interesting to me about the flash memory market is that it's all about the stacking. We've had, for a long time now, we've had 3D NAND. We've been stacking NAND on top of NAND on top of NAND. And the question has been, how high can it go?
Yeah.
Now, a couple of years ago, all the talk was about basically 100-layer plus flash memory, and that's basically mainstream now, right? And we're seeing some new levels. Talk to us about that.
Yeah, so this is one of those interesting things where NAND got a bad rap as it was getting smaller and denser. You were having all these problems with the die dimensions, the physical dimensions of the storage cell shrinking. When we went 3D, the storage cell got bigger, but we ended up stacking it and it becomes a skyscraper. So now we're in this kind of race that you're seeing that took place with like the Chrysler building and the Empire State Building. Thank you, I'm losing it today. But the idea is the taller we can go, the more bits we can get per density, but there's all kinds of different aspects about that. So the manufacturing process is now more important than ever, because as you get taller, just like when you're building a skyscraper, you have to think about the weight, the alignment, how you get everything to merge together. And when you get to these highest density stacks, I can build a great 100-layer stack, but I need to put another 100 layers on top of it. How do I align that? How do I actually drill that? And I'm putting so much material on the surface of the wafer, I'm now causing wafer stress. So it's really interesting that if you really are a geek like I am when it comes to wafer level stuff, getting taller is becoming a unique opportunity. And we've seen really tall semiconductors in the past. Look at a Xeon, for example. It's got hundreds of layers of different things going on, all logic based. But for NAND, it's something fairly new and different because we are drilling these holes, or they're calling them plugs, that are very, very tall, thinking Marinara Trench depth while you're still going to the top of Burj Dubai all in one shot.
And I think that the skyscraper metaphor is extremely valuable. Again, for the non-storage people out there listening, that's kind of how these things are. So just like a skyscraper typically has sky lobbies, maybe you don't know that. They've got express elevators that kind of take you to another lobby, and then from there you can take a local elevator to get to the floors in that section. We're seeing that with 3D NAND as well, in that you can't just have these things. You can't have hundreds of layers of flash just all addressable based on the local elevator, right?
Exactly. You do have to curate that because you have the string concept. There's only so many bits you can stick together without having some kind of control around it or the elevator, and it's a really good example. So, and at this particular event, SK Hynix is running the lead in the game, if you will, with the announcement of a 321 layer NAND. So.
Well, in the past, when companies have announced a new layer achievement, the other competitors have been very quick behind with similar products. I'm going to just go out on a limb and say I'm going to assume that most of the other competitors are going to come out with 300 plus layer NAND soon.
Yeah, and it's interesting because it's not necessarily the layer count's one piece. It's a manufacturing prowess. It shows some great innovation from that perspective. But the die density per device is also interesting because you're getting to 1 terabit, 2 terabit die, and that's starting to create the problem for things like if I want to do a 128 gigabyte USB or computer, that's like one device now. So it's starting to show that capacity challenge that even hard drives faced, based both on the manufacturing but also the density of the devices too.
Yeah, that's a real good point, and we're already starting to hear that from some people that some of the smaller devices now are down to, as you say, one chip, and they're slower because they don't have the ability to have that parallelism. So anyway, keep an eye on this space. I think that the news here is that SK Hynix is showing us that yes, we can get into this 300 layer world, and that manufacturing is developing in that direction.
Exactly.
So another thing that we're seeing a lot of here is technologies that make SSDs and data storage generally just sort of work better. So we've got software-enabled flash, we've got flexible data placement being talked about on stage, and of course DPU products are here as well. Talk to us a little bit about these devices.
Yeah, so what we're seeing is now that we've got flash mainstream, it's how do we make flash better? So companies have started creating different aspects of how to manage data placement. We have this whole, as I was talking, we have a string of cells. You can only program and erase and that kind of stuff in certain forms. How do we get the user more flexibility to do that? So Kyosha, for example, has launched their software-enabled flash consortium or organization where they're trying to open source this aspect of let's give the user a little more control on how the data is being put down. Helps with things like endurance, wear out, and even performance, because if I know where the data is going, I know when I can erase it and where I can put the new data, which is traditionally done inside by the FTL, but as we're getting to an all-flash world, we want people to be able to put data where they want it. And so another good example is the work being done in what's called flexible data placement, and that's being driven in both NVMe and other organizations to help make it easier to let the user, and Meta's a very high proponent of this, they were on stage talking about it, on allowing them to take a batch of data and specifically place it around, and then they can just come back and stripe through it the way they want to versus trusting the SSD vendor to do it. And that helps with things like the WAF, or write amplification factors. And then as far as getting into the DPU space, how do we manage a whole bunch of these products now? And so we see a bunch of organizations that are releasing solutions that are able to take care of that. So MaxLinear, for example, is releasing their Panther 3, which talks about a 12-to-1 data compression capability, but it's only able to get there because it has things like flash behind it now.
And another aspect that we're seeing, of course, is our friends from SNIA. So again, I'll mention that SNIA's Storage Developer Conference is coming up, and we'll be there with Storage Field Day. But right now, SNIA is here as well at Flash Memory Summit, showing off some of the things that they've been doing. One of the announcements they've made is that the SCSI Trade Association has merged with SNIA's SCSI Development Forum. I mean, I consider that to be kind of a link to the past. I mean, SCSI is not irrelevant by any means. SCSI is still a very important protocol, but by bringing it into SNIA, I think that that's a positive move overall, wouldn't you say?
Yeah. So at SNIA, so I'm also on the SNIA board of directors, so it's a fun thing here. We're shifting the focus of what we're doing. Everyone saw us as the Storage Networking Industry Association and thought storage and networking only. It's really more about what we're doing to help users manage their data. And so we're kind of changing this focus to being experts on data, and when it comes to that, that includes transports, which it always has, but it wasn't really in the name. And so having the SCSI Trade Association come in, we're allowed to combine those assets, those resources, and support the existing infrastructure while we look at what's next. We have a lot of other partnerships within SNIA with CXL and NVMe and all that kind of stuff. So this is a natural foot forward on how to keep relevance in the market for SCSI, as well as help SNIA bolster the experts on data aspects of things.
Yeah, and I would call out too that SNIA is really working aggressively to try to improve data management specifically. We're going to be doing an interview today. I'm going to take a look at Swordfish, which is a cross-platform storage management initiative. We'll be posting that as a Gestalt IT Tech Talk later, probably next week. And SNIA has a lot of these projects where they're really just trying to kind of move the ball forward on storage management overall. And honestly, in my opinion, even beyond storage, I know that SNIA is really the storage group, but a lot of the things SNIA talks about are really data management, data placement, and trying to move the overall technology picture forward. And I really appreciate that the companies or the organization is working on that.
Exactly. And it's a great opportunity to just see that continue, to your point, analyze data, move data, format data. We're not changing the user data, we're making it easier for people to take care of that.
So next up as well, it wouldn't be 2023 without a lot of people talking about CXL. So there's a lot of CXL presence here at Flash Memory Summit. As you know, we did a season of our Utilizing Tech podcast focusing on CXL. If you're interested in that, I do recommend going to utilizingtech.com and learning more about from season 4 about the CXL spec. But essentially, as we said there, and as I'm going to say now, CXL is getting real. We're seeing a lot more interest in it. There's a lot more talk about PCI Express 5. We talked about that on the client side, but also here in server in combination with CXL. We're seeing CXL 2 products coming out, CXL 3 as well. And also we're seeing some really clever ideas about applying CXL to storage questions. What do you think about using CXL for storage?
I think it's a natural evolution, the concept of the Compute Express Link. It's a protocol on top of PCIe Gen 5 and Gen 6 and Gen 7, and it's trying to create that better synergy across the different technologies behind it. So when we've had our DRAM bus and we've had our storage bus, you have the fast bus and the slow bus. And sometimes you need memory on the slow bus, and this is the opportunity CXL brings it in, and that's how it overlaps with the concepts of storage. So you're going to see, or have already seen, some announcements from vendors about CXL memory plus storage in one device. We could see CXL come out as that. And so there are innovations in this space that are very unique and creative, if you will. So one of the announcements that was made here at the show was Micron and Microchip have gotten together. So Micron's using Microchip's CXL controller to support E3.S CXL expansion cards that go into those new servers that we have. So now you're putting memory in the front of the box, and so you can get your memory to a larger footprint on a slightly slower than directly attached DRAM bus, but you get that expansion factor. So you get better performance, but you get that memory array that you need. And in the world of AI, that's actually becoming relevant because most AI work that's done is in real-time DRAM.
Yeah, and you need a lot of memory to do machine learning, ML training, for example.
Yep.
And also what we found on the podcast and talking to some of the experts here is that the performance hit from putting memory on PCI Express bus is not as bad as you would think.
Exactly. Yeah.
In fact, the latency to get to that memory is really not much worse than the latency to get to memory in multiprocessor systems, remote memory. And what this means is ultimately, I think, a kind of a rethink of what memory should look like. So from my perspective, I'm looking at technologies like CXL along with technologies like UCIe, which is a way to allow chiplets to talk to each other in a similar fashion to CXL, as well as, what does this mean for the shape of the server? And that's one of the things that I'm going to be looking for, and one of the things that I'm hoping for is that we'll see technologies like on-package memory and high bandwidth memory combined with this tiered memory concept and having, so you have a high performance memory on the chip, you have vast, not from the company, large amounts of memory on CXL that you can add to, that you can upgrade, and then you have storage as well in kind of on CXL. And not only that, but then you can break out of the server. And that's one of the coolest things that I saw here. A company called Lightelligence, which was working on an optical chip, an optical processor for a while, is showing a PCI Express expander or extender that uses optical technology. So basically you could mount the CXL memory remote. Now, by itself, PCIe can go a couple of meters, but with optical technology, you could actually mount that in a different rack, the other end of the data center.
Exactly.
That's pretty cool. And when we talk about sort of disaggregation with companies like Liquid and what Memberge is talking about and sort of the promise overall of CXL, the idea of extending CXL over optical, I think, is pretty important.
Yeah, that's always one of the challenges when you get these new technologies interfaces is the distance between point A and point B induces all kinds of interesting latencies. And with memory, it's more important. As you mentioned, CXL has a limited amount of latency increase, but when you start expanding it off, so we got, we first had just a bunch of disks, a JBOD, and we get to JBOF. Now we get to the opportunity with something like an optical connector and that lossless connection to get to a JBOM, just a bunch of memory.
Yep.
So.
And a lot of the technologies and concepts that we developed in storage networking over the years, back earlier in our career, a lot of that stuff is kind of coming back, and I'm starting to see people talking about, CXL3, we're talking about switching, we're talking about memory chassis and things like that, memory storing, memory pooling, memory sharing, all the things that we did with storage now we're going to be doing with memory. And I should also mention that the PCIe SIG is also working on PCIe over optical. So I think there's a really good chance that this is not going to be a wild futuristic concept of extending PCIe over optical links. I think this is going to be how it's going to be done in the future.
Yeah, and it's great to see that there is that emphasis from the transport protocol that's being used to the basis of everything driving that optical direction. So you do need that underlying support to have the success of these tools and technology.
Yeah, and so I really am excited about the direction that CXL is going. After talking to like everybody in the industry on the podcast, it's really cool to see it getting real and to see it continuing to have momentum.
Yep.
And for me, the big thing too, I'll just say, is I'm really excited to see the storage industry particularly embracing CXL, because I think that this could be a transformative aspect just for the shape of computers, for the shape of servers and racks and data centers, and storage is going to be right there, not just memory. CXL is not just a memory expansion technology.
Exactly. And it definitely will evolve over time, that we're going to see multiple vendors have already prototyped mixing DRAM and NAND together in a CXL device, and so it has a great opportunity to see the prowess of it come forward. So it's a unique space that it's a look and effort where we're trying to put them together in a new way. We haven't really done it before. It's the whole thought process of things like computational storage and computational memory, and not just thinking of memory as memory and storage as storage, but how do we properly bring them together? And that's what one of the success points of CXL, and one of the efforts that's being driven by one of your more recent announcements, Ultra Ethernet, that just got launched that you talked about last week. So.
Yep. Absolutely. There's some very, very cool stuff happening here. So I hope that our listeners have enjoyed this dive into storage. As you can see, I know that sometimes people are like, oh, storage, hard drives, tapes, blah, blah, blah. That ain't what it's about anymore. I mean, storage is absolutely a critical component, and there's a lot of exciting development happening there.